All right, here we go. The volume of prisms, cylinders, pyramids, and cones. This lesson is about these special solids. You probably heard these terms, of course: prisms, cylinders, pyramids, and cones. But we're talking about the volume here today. The volume is the space of three-dimensional figures. 3D, meaning it has both length and width and height, or not both, all three of those things. There's measured in cubic units, because like centimeters cubed, liters, gallons, ounces, etc. There's all, but anyway, those are things you're familiar with. But it's the cubed if we're talking about inches cubed. All right, bases. What is the base? This is different than the base when we're talking about the area of things. Now we're talking about the volume. The bases are the two congruent parallel sides. Two congruent sides that are in parallel planes. And in these three examples, these are all prisms. The shaded regions are the bases. So the first thing you'll want to do is identify what are the bases. The shaded regions here, these are rectangles. So we call this a rectangular prism. In this case, the two parallel congruent, it's exactly the same size and shape, running in parallel. Those are pentagons, so that would be called a pentagonal prism. And then number 3 over here, you can see that those are triangles. That's a triangular prism. So the bases is the most important part. Being able to identify the bases is the most important part, and sometimes slightly difficult part for people to see, which things are the bases. Now, it's worth noting here that in a rectangular prism, these sides on the left and right, or the front and the back, however you're looking at, they could also be parallel and congruent. So it doesn't really matter which ones you use on a rectangular one. It matters a lot on the other shapes, like the pentagonal and the triangular one. If it was a hexagon or an octagon or whatever agon, it doesn't really matter. But rectangles, it can flip it on its side. Now, the other thing that we're going to need is the altitude, or the height. This is, well, I'm sorry, quick note. The other faces, the ones that aren't the bases, the other faces of these, they're always going to be rectangles on a prism. Or actually, more likely, they're parallelograms, because if it's slanted like this one, those are parallelograms. If they're not slanted, they're rectangles. So back to this. The other thing that we're going to need is the height. This we won't use this for this lesson, but the height is just like it was with area. It's the perpendicular distance between the bases. But now we're talking about capital B bases, the base of the prism. So on numbers 1 and 2, these edges over here represent the height, and the ones we'll be looking at, that's going to be the case. It's going to be like this edge that connects them. If it happens to be a slanted one, that's called an oblique prism, then you'd have to have some measurement here that's a perpendicular one, because these are not perpendicular. There'd have to be some measurement that is to connect this base to that base. We will be seeing ones like numbers 1 and 2 in this lesson. So, on to the big part of this. These would be called right prisms. This one's called an oblique prism, just as an FYI. So how does volume work? Well, let's imagine we have a loaf of bread. If the total amount of bread we had, well, if we knew the amount of bread that was in this first slice here, and then we knew how many slices of bread we had, the total of all of those pieces of bread, would get us our volume of bread, right? So how could we calculate this? We could calculate the area of this first piece of bread times the number of pieces, which in this case would become my height. So like these are all just slices of the bread, all added together. But the easiest way to do this is take the area of this slice times the number of slices, or the height. In general, that's what we're going to do here. The volume of a prism is a very simple formula. Capital B times capital H. What do I mean by capital B? I mean base. But this time, I mean the area of the base. Now we're talking about the two parallel, congruent sides. Now when I'm talking cylinder, when I say base, I mean capital B, big base. And I'm talking about a shape, a triangle, a rectangle, a circle, a pentagon, or whatever that it is. And so whatever that shape is, you find the area of that shape. And then, and you'll just use the formula for it. And then capital H height is the height of the prism, the distance between the bases. So it's the segment that connects the two bases. It's actually really simple. Let's look at example 1. Example 1, the first thing we want to do is identify what are the bases. Well, do you see the two parallel and congruent sides? Hopefully you do. It's these two triangles that are parallel and congruent. So we have this right triangle is actually our base. So we're going to need to figure out the area of that triangle is big B, the area of our base. That's 1/2 times 4 times 3. Remember, we have the right angle here, 3 times 4. That's our little b, little height of our triangle. Base times 1/2 base times height comes from that guy right there. So capital B comes from the area of that triangle is 1/2 times 4 times 3 is 6 kilometers squared. Now the height is the distance between those bases. That's given to us as 9 kilometers in this case. So the volume is the area of the base, the area of the triangle, which was 6, times the height, 9. Gets us 54 kilometers cubed. Volume is a cubed. So that's all there is to it. All the work really is identifying the area of your base right here, multiplying it times the height. On example 2, I'm going to call the top and bottom my bases. Those are rectangles. So the area of that rectangle is 5 times 16 is 80 units squared. My height is given as 15, so the volume is the area of the base, which was area of the rectangle, which was 80, times the height 15, gets us 1,200 units cubed. Example 3, we got over here a cylinder. The area, or the base, are circles. Bases are circles. The radius is 6, so the area of my base, the area of the circle, is the radius squared, 6 squared times pi. 36 pi centimeters squared is the area of my base. My height is given as 8, so now the volume is 36 pi times 8. Gets me my answer over here, 288 pi centimeters. That should be cubed, my bad. Cubed. Okay. All right. That's cylinders. Moving on to pyramids and cones. Let's the difference between a prism and a cylinder. Well, there's two bases in a prism or cylinder. In a pyramid or cone, there's one. That's the biggest difference. In this case right here, and then the lateral faces, which we're not really going to talk about in this lesson, but I'm just throwing this out there. The lateral faces, the other sides are parallelograms here. They're triangles in a pyramid/cone. If the height is the same and the volume is the same right here, what we're going to talk about is what's the difference between these things. And I'm going to show you another little video if I can, if I get power. But the volume equals 1/3 times base times height. Again, capital B is the area of your base, and capital H is the height, the distance between. So in this case, the height is going to go would be 8 from here up to that vertex of my pyramid. It's the same thing if it's a cone. But the only difference here is it's the capital B, base, times the height, times 1/3 is the volume of a pyramid or cone. So 3 of these equals 1 of those. All right. Oh, and alternative formula, this looks simpler too. You can take the base times the height, capital B times capital H, divided by the 3. That's equivalent. So those are your formulas. Let's go give it some use. Number 4, what's my base? My base is a square. So the height is 12. So the area of the base, that's going to be 10 times 10. 10 squared is 100. So now that I have my big B is 100, my height is 12. It's 1/3 times 100 times 12. That ends up being 400 units cubed. All the work's really right here, calculating the area of the base. What is my base right here? This is a triangle, and it's marked right there as with a right angle. That's a right triangle, that base. So how do you find the area of the right triangle? This is where all the work really is. Well, there's my right angle, my little b, my little h. I need 1/2 little b, little h of the triangle. My base is 6, or my height is 6. What is my other one? Well, we got to use the Pythagorean theorem. 6 squared plus something squared equals 10 squared. Hopefully you know by now that's 8. So the area of that triangle, which is my capital B base, is 1/2 times 6 times 8, which is 24 feet squared. My height was given as 15 feet, so it's 1/3 times 24 times 15 gets us 120 feet cubed. Number 6, that's a cone. So my base is a circle. The radius is, well, it's marked for us. Oh, we got a right triangle. Look at that. The radius, the 12 and the 13, that's a right triangle. So we can calculate the radius. R squared plus 12 squared equals 13 squared. R is 5 from calculating that. So now the area of the circle, the area of my base, is 5 squared times 5. That's 25 pi. That was the hard work. The height was 12, so now it's 1/3 times 25 pi times 12. It's 100 pi units cubed. If you'd rather type that into your calculator, 100 pi is approximately 314.16 units cubed. Either one of those answers would be good. Okay, so the work on all of these is in calculating the area of the base. That's true for all of these 4 things. Number 7 and 8, a little bit of application here. If the cone and cylinder have the same height and the same radius, the cone and the cylinder, find the ratio. Well, the difference is that the volume of the cylinder is capital B times capital H. The volume of the cone is 1/3 times capital B times capital H. So the ratio is all about that 1 to 3. That's right there. It's 3 to 1 or 1 to 3, depending on which order you're talking about. Number 8, a cylinder question comparing if the bases and the height have the radius and the height have slightly different switched values here. So the capital B times H, the area of the circle times the height, since we're talking about a cylinder. The area of the circle is pi times the radius squared times the height. Just to kind of simplify my work here. So for cylinder A, my radius is 4, my height is 6. That simplifies out and becomes 96 pi. For the volume of cylinder B, 6 is the radius, 4 is the height. Well, that becomes 144 pi. So which is bigger? Volume of cylinder B. All right. So there's 2 important formulas. First one is volume of a prism or cylinder is capital B times capital H. The volume of a pyramid cone, volume equals 1/3 times capital B times capital H. And there you have it. Have a good rest of your day. Bye.